So, for a molecule to be optically active, what has been observed is that the molecule should not be symmetrical. That means we have to check whether symmetry is absent in a molecule or not. That is the theoretical way to figure out whether a molecule will be optically active or inactive. If molecule is unsymmetrical, it will be optically active. If molecule is symmetrical, it will be optically inactive. So we need to understand symmetry. So we have symmetry elements. So what are the symmetry elements? Symmetry elements are such as center of symmetry, plane of symmetry, alternating axis of symmetry, and the fourth one is axis of symmetry. If these all elements are absent, that means molecule is unsymmetrical and we have optically active compound. But we find very difficult to check axis of symmetry and alternating axis of symmetry. So for easy calculations or easy understanding, what a student can do is he can figure out whether plane of symmetry and center of symmetry are absent in the molecule or not. If they are absent, then you can say molecule is optically active. Alright. So plane of symmetry, in short, we call that as pos, and center of symmetry we'll call that as cos. If pos and cos are absent, molecule is unsymmetrical and it will show optical activity, right? That means it will rotate plane polarized light, right? So what is plane of symmetry and center of symmetry? You can easily understand. I will explain it to you through an example. If a molecule is something, like this, you have a center out here. If we go in different directions, if I go this side, I get a CH2 group over here. If I go this side, we get a CH2 group here. We go this side, we get CH2 group here. We go this side, we get CH2 group here. That means center is symmetrical. That means we have center of symmetry present, or we have cos. In short, center of symmetry is present in this molecule. Whereas if I take this molecule, CH2 is here, CH2 is here, CH2 is here. But if from center, if I go upwards, we get CH2. But if we go downwards, that means if we go from center in opposite direction, we should get same group. Then we will say it is center of symmetry is present. If we are not getting the same group in going in opposite directions, that means center of symmetry is absent. So here center of symmetry is present, but in this molecule center of symmetry is absent, right? So I think you must have understood by now what center of symmetry is. Similarly, if I am talking about plane of symmetry, so plane of symmetry is something that we can cut the molecule in two equal halves. If I take this molecule, let's say benzene I can cut this molecule, or for that matter, I'll take another molecule because it is a planar molecule. Planar's molecule is always having planar symmetry. So it is not a planar. I'll take another molecule. I'll take something like this. I'll take something like this, right? This molecule. Now, if I cut this molecule along this, then I will have two equal halves. So this is called as plane of symmetry. If there is a plane through which I can cut molecule in equal parts, then the molecule has plane of symmetry. And if it has plane of symmetry, then it will be optically inactive. For example, if I take this molecule, I can cut this molecule in two equal halves along this plane. This is a plane. I can cut this molecule in two equal halves. This half and this half is exactly the same. That means it has plane of symmetry. In short, pos is present. Pos is present, that means optically inactive compound. Optically inactive compound. Alright. So optically inactive compound, and the compound which is optically inactive due to plane of symmetry is called as meso compound. Alright. Meso compound, or we can say this as mesomer. The net rotation will be 0 for this molecule. What are the conditions for a molecule to show optical activity? Conditions are, I am summarizing this. Molecule should be unsymmetrical, that is dissymmetric or unsymmetrical molecule. So first condition is symmetry should not be present. for open chain compound, molecule will be optically active if it has no plane of symmetry. I already explained it to you that plane of symmetry and center of symmetry both should be absent. Then these are conditions for optical activity, optically active compound. If any one of these is present, they both should be absent. If any one of these is present, then compound would be optically inactive. All right, and if it is optically active, then compound and its mirror image will be non-superimposable and they will be called as enantiomers. All right, so this is it for now. Thank you.